Good morning, everyone. First of all, I'd like to thank the organizers for the opportunity to present here the so-called IceCat-2, that is the updated IceCube event catalog of alert tracks. All of you know that IceCube is a cubic kilometer neutral telescope located at the South Pole. It is taking data since 2011 in its full detector configuration, and you know that a few years later, in 2016, the IceCube collaboration started to launch the so-called real-time program. So we started to release public neutrino alerts within 1 minute after the detection to trigger external telescope for multi-messenger observations. And one of the main targets of this program is the detection of track-like events that are characterized, generated by charge current interaction of new neutrino originating from astrophysical cosmic ray accelerators. And these are the best signatures that we can we aim to for astrophysical purposes, because actually after this interaction, a secondary muon is produced and a long muon path is released inside our detector. And so thanks to the photomultipliers in IceCube, we can reconstruct quite well the direction of the muon. And so we can also reconstruct in turn the direction of the neutrino. And note that there is this kinematic angle between the neutrino and the muon, but as you can see here, the higher the energy of the neutrino and the lower this angle, so actually we can reconstruct much better the direction of the incoming neutrino. And 1 year after the launch of the real-time program, there was the first success of the real-time program. This was the first ever identification of any energy neutrino source. And I'm talking about the famous Blazar Texas, so 506 plus 56. This was, again, the first identification of a high energy neutrino source, and this was a success of the cooperation between data from the IceCube neutrino telescope and gamma ray satellites. Indeed, the IceCube neutrino telescope was able to alert the community only 46 seconds after the trigger, and then the gamma ray satellites as Fermi and Magic were able to point at the same direction of the sky, discovering this blazar flaring in gamma. And a few years later, in 2019, there was the expansion and improvement of the alert selection in the real-time program. And since this time, we are releasing now gold and bronze alerts that are characterized by an average probability of being of astrophysical origin of 50 and 30% respectively. And this is what we have still now active. And let me recap, which is the track alerts workflow. So you know that, and as already said, actually, after the detection of a neutrino alert, so gold and bronze alert, we release a GCN notice that contains the results of a fast and simplified reconstruction algorithm that is processed at the South Pole. And then a few hours later, we update the community with results obtained running more sophisticated reconstruction algorithms that are processed at North. And we publish a GCN circular with refined best fit directions and angular coordinates and a rectangular error region around the best fit direction. And we update also the GCN notice that we released at the beginning. And a few years ago, the IceCube collaboration released the first catalog of public alerts, the alert tracks. This was a public release of 348 alerts from 2011 to October 2023. This basically contains all the alerts. This was motivated by the upgrade of 2019, because after this upgrade of the alerts, since the start of the real-time program were reprocessed with the upgrade that was introduced in 2019. And then all the events since the start of the data taking were reprocessed. So basically, this catalog contains all the alerts, but also all the events observed since the start of the full detector data collection that would have triggered an alert if the program had been in place at that time. And this is how, the IceCat-1 catalog looked like. You can see here the best fit directions of the 348 alerts that are contained inside this catalog. But now it's time for IceCat-2. So we are producing an updated catalog, and let's see why. So let's come back to the track alerts workflow that I presented before. Actually, as already Marcos said yesterday, we have introduced an important update at this process level. So since September 2024, we are now running new reconstruction algorithms for this second step that improve the angular resolution of muon track and the statistical coverage of the uncertainties around the direction of these tracks. And you can see also a reference of these improvements in this ICRC proceeding. And this is why we are producing IceCat-2. So first of all, we'd like to improve the directions of the IceCat-1 event. But it's not only this, actually, we are also improving the IceCat-1 catalog because we are now able to exclude some events that we know that are atmospheric muons, so not signals, because actually we can now use the iStop detector, that is a surface detector used for cosmic ray haze shower studies in IceCube, that can be actually used to identify if a muon track, so a track-like event that we trigger in the detector is associated to a cosmic ray shower. If so, this means that this is an atmospheric muon. And so thanks to this, we are able to remove 8 events from the IceCat-1 dataset. Then, of course, we'd like to add the new alerts since the last release of IceCat-1 that was in October 2023. And the preliminary catalog that I'm presenting today contains events until January 2025. But when we release the final catalog, we plan, of course, to add also the other alerts after January 2025. And we are also using now for the reprocessing of alerts the most up-to-date data processing framework and calibrations that we had so far. And you see in this plot the IceCat-2 sample, the cumulative number of alerts. So this represents all the alerts in black. Then we have gold alerts and bronze alerts. And you see here in this box the average rate of these alerts. And the green region highlights the new alerts that we're adding since the last release of IceCat-1. And the shaded region represents the Poisson expectations, plus and minus sigma. So the Poisson expectations is represented by this dashed line and this shaded region. But and this is how the IceCat-2 catalog looks like. So you see, this is the equatorial sky map, the best v directions, and the 90% contours around each event. And you see that these contours are quite small, let's say, with respect to what we are used to. But to stress this, I'd like to show the comparison between IceCat-1 and IceCat-2. And let me start with in this case, you simply see the comparison between the best v directions. So here you see in blue the same events that I showed before, so the events that were part of the IceCat-1 catalog, and then in red you see the IceCat-1 alerts with updated IceCat-2 reconstructions. But you see better the difference in this distribution. You see the distribution of the number of alerts as a function of, this is the angular separation between IceCat-1 and IceCat-2, 50% quantile, 90% quantile. And you see that 50 and 90% of the alerts are characterized by an angular separation between 0.6 and 1.6 degrees. But the most important improvement we are introducing is actually the significant reduction in localizing uncertainties around the best v directions. And you see this in these plots, in these distributions. At the left, there is the distribution of the area 50% around the best v direction. At the right, the area 90%. The distribution in red are IceCat-1 and in blue IceCat-2. The dashed line represents the median values. And for example, if you focus on the 90% distribution, you see that for IceCat-1, the median of the uncertainties was 6.2 square degrees. Now in IceCat-2, 1.3 square degrees. So there is a factor 5 between the two, and between 4 and 5. And you can see also that the distributions, it's the same also for the area 50%, the distributions are now narrowing with respect to the one of IceCat-1, sorry. So this is a great improvement with respect to the old catalog. And you see this also in this other distribution that show the ratio in logarithm between the area in IceCat-1 and IceCat-2. In blue, you see this ratio referring to the area at 50% around the best v direction, and in orange at 90%. This is the median again, and you can see again, that the median improvement is between a factor 4 and 5. And now, here you see the equatorial scale map of the IceCat-1 event again with the rectangular errors, because at the beginning I told you that with the GCN circulars, actually at the moment we are releasing the rectangular error region around events. This is what we were releasing. Basically, this represents what we were releasing until September 2024, before we introduced the usage of the new reconstruction algorithms. And now I'm showing you the same map with a rectangular error obtained after running the new reconstruction algorithms. So this actually reflects the improvement that we introduced in September 2024 in the alerts. Thanks. That we release with our GCN circulars. And now I wanna leave you with some checks that we did. So we now have these new catalogs. Of course, we wanted to check some spatial coincidences with relevant sources that have been identified over the years, correlated with the IceCube alerts. And first of all, of course, we had a look at the famous TXS. So we checked if the blazar is still inside the new contours. This is the case, fortunately. So you see here the position of Texas. The IceCat-1 contours are this one in red, 50 and 90%, and IceCat-2 is in blue. So you see that TXS is still inside. So the first transient identified as potential neutrino source is still a neutrino candidate, even though now it's within the 90% contours and not anymore within the 50% contour. Then there is also another source that is quite interesting, that is the Cipher galaxy and the C7469, because in the past, as you can see in this paper, there were two neutrino alert candidates that were found inside, consistent with the position of NGC 7469. This is this plot on the left show the contours from IceCat-1, and this is the source position. And on the right, you see the corresponding contours in IceCat-2. So you see that the position of this Cipher galaxy is still contained within the contours of both neutrino alerts. This is not the case for some high interest static disruption events. In the past, there was these TD candidates. This represents just the most famous one, but there were also some others. But for now, we check this, that have been associated with high energy astrophysical neutrino alerts in multi-messenger follow-up occurring at the days after the maximum of the optical ultraviolet luminosity of this object. And in all these cases, you see that the TD position is well outside the new contours in blue. So it seems that associations between these TDs and the corresponding IceCube neutrino alerts are disfavored. With this, I conclude my talk and I leave you with my summary. So basically, we are preparing this new IceCat catalog, and we are almost ready to release the catalog that contains a great improvement with respect to the past. We presented this catalog already at the ICRC conference, but we are preparing the full paper and a public release alongside several analysis on source population. Thanks a lot for the attention.